XR 会議2022にご参加いただきありがとうございます。 XR 会議2022はプラチナスポンサーパナソニック株式会社、株式会社シフトール、シンク&センス、株式会社ナイアンティック、日本マイクロソフト株式会社、ソニー株式会社ほかスポンサー各社の協賛で開催いたします。セッション開始まで今しばらくお待ちください。まもなく次のセッションが始まります。コメントは配信画面右のコメント欄からお寄せください。またスクリーンショットや SNS への投稿に関してはサイト上部の記載をご確認ください。お時間となりましたのでセッションを始めます。コメントは配信画面右のコメント欄からお寄せください。またスクリーンショットや SNS への投稿に関してはサイト上部の記載をご確認ください。それではどうぞ。
Hello and welcome. My name is Shahrabi and today I'm going to be talking about the making of Puzzling Places, which is the latest game we have made, and I would like to talk a bit about the stories around Puzzling Places and Realities io. So at the beginning I'm going to be introducing myself, who I am, the things I have done. Then I'm going to be introducing the game to you, for those of you who do not know the game. Afterwards I will be talking about our motivation behind creating Puzzling Places. We have this entire story of how we came to decide to make Puzzling Places, which I think is a very interesting one, so I would like to share that with you. And afterwards I would be talking about how we decided to make different features, our development process, our relationship with, let's say, our player base, as well as with the different platforms we worked on. So as I said, my name is Shahrabi. I am an Iranian technical artist, art director, and programmer. On Puzzling Places, I had various different responsibilities. These responsibilities was from anything like game design and art direction, as well as programming, tech art, graphic programming, optimization, so on and so forth. We are a very small team, so many different hats for the same individual. I'm based in Berlin, so it's Realities io. And in my free time, I just love to experiment and write code. I love to experiment, especially with graphic techniques, with tech art, and I love to write about them. I have a blog where I write my learnings and try to share some of that with the community. You can see some of these experiments here. They range from fluid simulation in Unity in compute shaders to, on the right, multi-scattering fog on a screen space ready for VR use. If you wish to know more about me, you can either go on my Twitter or on my weblog. But now let's talk about the game. Puzzling Places is a three-dimensional jigsaw puzzle in VR. The way you can imagine it is like this. Imagine a hyper-realistic miniature model in front of you. This model has been chopped in many different pieces, and it is your job as a player to kind of put them back together. The game is centered around the feeling of satisfaction, meditative game flow, and generally a positive feedback loop. All these locations you see in Puzzling Places are actually real-life locations which have been converted to three-dimensional models using a technique called photogrammetry. I will be talking about that in a bit. The game is already out there. It's on Meta Quest, which is a mobile platform, and PlayStation VR. At the beginning, we first released a prototype of the game, a demo you could say, for free on SideQuest. SideQuest is like a backdoor on official marketplace where more experimental games and experiences can be shared with Quest players. After SideQuest, we released the game on AppLab, which is a more official version of SideQuest, and finally we brought the game last year to VR, to the official store. As we brought the game last year, we met with overwhelmingly positive feedback from our player base, which we are very thankful for. The game has been, as a matter of fact, the highest rated game on the MetaQuest store for around a year. Since we have such a nice and dedicated fan base, we have been putting out puzzles monthly. We try to put out 4 to 6 new puzzles every month. Some of them are paid and some of them are free. So I would like to talk about the story of Puzzling Places, how we came as a company to decide to make this specific game. And it's hard to do that without talking about photogrammetry. What is photogrammetry? As I said before, photogrammetry is the process of taking a bunch of pictures from a location, putting these pictures in an algorithm, and automatically generating a three-dimensional model, which we call, and everyone else also calls, a mesh. So basically, photogrammetry is spatial photography. You take a bunch of photos, a process we call scanning, and at the end you get a model that's hyper-realistic and has all the colors and textures on the surfaces of those models. You can see here on the left my colleague Azad taking a bunch of photos from our elevator, and on the right the three-dimensional model that comes out of it. You can scan with whatever you want. You can scan with your mobile phone these days, since the mobile phones are so good. But typically we scan with DSLRs, and you can scan things like small objects, but you can also scan rooms, and you can even scan mountains and cities and entire landscapes. The example you have in front of you is a project we did with the car company Audi. We launched a bunch of different drones in the air, which had some sort of protocol with each other, and these drones automatically took a bunch of photos, which gave us this huge three-dimensional model. So what makes photogrammetry special? Why do we care about photogrammetry? You see, every time you want to create a model or an asset for some sort of entertainment product, this could be film, animation, games, one of your biggest challenges is to make believable assets. Believability is not the same thing as realism. As a matter of fact, you can have highly believable assets that are also highly stylized. So what is believability about? Believability is about whether the viewer believes that this object has actually existed in your fictional world or not. In other words, the viewer looks at that object And if it feels out of place in the fictional world and the rules you have set for that world, the viewer just simply wouldn't believe that this object is real. So how do we do this? How do we make objects believable? Well, if you have, for example, a metal cube laying around in a room for 100 years, you're going to see things like environmental effect on it, such as weather damage, usage, dirt, so on and so forth. And you need to accordingly create these dynamics also on the surface of that model. This is a very costly process. It costs you money and it costs you time. You need very good artists. You need very good artists because the person who applies these effects needs to have a very deep understanding of the object and of the world around it. It needs to understand what is the object and the essence of it, how do people use it, and also all the dynamics around it, such as weather and temperature and humidity, and how this all affects that specific object. Finding very good artists is hard, and giving them the time needed to create these effects is very costly. Photogrammetry kind of bypasses all that problem. How does that work? Because photogrammetry is basically a spatial photography. Whatever you capture in your scan is what was actually there in the real world. We like to say that every graffiti, every scratch on the wall, every piece of trash on the ground was made by an actual person or a real-life dynamic that led to that thing being there, such as weather effects. Just to give you an example, if you're walking around in one of our scans and you see a trash can on the ground from a soda drink, you need to think that an actual person decided on that day, I'm thirsty. They went to a shop, they bought a soda drink, then they decided to come to this specific location. They got there, drank it, decided to be asocial for some reason, maybe they couldn't find a trash can, and they just threw it on the ground. And that's how that thing came to be there. So there is a story behind everything in the real world, and photogrammetry captures that. In games and media generally, also in film, this is called environmental storytelling. Now, why is environmental storytelling important? It's important because the stories of these environments are by extension the stories of people who actually lived in these environments, people who actually populated these environments. And we as humans care about other humans and their stories, right? We care about subjective experiences of others. And we as companies specifically really care about that. Why? Well, I guess you could say it's a bit in the genome of our company, because many different members of our company really care about cultural heritage, they care about personal subjective stories, and how these stories are reflected on the environments where they lived in. I'm going to give you a very simple example. For example, this is some of our team members. On the left, you have David Fensterwalde, one of our early co-founders, who's unfortunately no longer with us. And he came from archaeology background. Archaeology was the place where he saw for the first time the potential of combining photogrammetry with VR for some sort of entertainment and storytelling purposes. They use archaeology. In archaeology, they use photogrammetry a lot for different things such as documentation, as well as measurement, and so on and so forth. Another example is Azza Balabanian, my colleague in the middle. He has done a lot of work for preserving Armenian cultural heritage. The building you see there is a scan he did, and he has gone around in places like Lebanon, Turkey, or Armenia, trying to capture these locations that are related to the cultural identity of the Armenians. Me, on the right, personally, I love history. And I love the version of the history that I like to call the lived-in history. History is lived in by real people, and every time I see one of these grand palaces, I like to think that actual real people lived there at some point. And I like to do these small projects for myself where I try to reconstruct those locations to the state they were in at the time they were actually lived in. You can see one of those paintings there. So most of our team members really care about, well, let's say cultural heritage and stories and how that reflects on locations. And we would like to communicate that with you as a viewer. We like to go to a place that's amazing, that has a lot of stories. We like to scan that, and we like to give that to you. But there's a problem there. It's really hard to communicate. There is a gap between the subjective experiences of different people, and to truly understand a location, the story, and the story of its people, you need to bridge that gap, and that's very hard. As a matter of fact, we found out it's very hard to make it so that people actually pay attention to what you're showing them. So to go a bit back, we had these amazing locations we have scanned. Either we scanned it ourselves, or we worked together with different partners to bring these locations to VR. We made an app called Realities, which is still available on Steam. You can go and download it if you wish. In Realities, you could, move around freely in a virtual environment that was populated by these photogrammetry scans. So you could go to a location, explore it a bit, and you could switch from one location to the next. Our hope was that people would go to these locations, have a blast looking at all these details, try to figure out what the stories behind them are, and come out with a deeper understanding of the world around them. That's not what happened. We would put people in VR, give them the headset, they would go to these locations, and then they would go and skip from one location to the next super fast. They would just go 1, 2, 3, 4, view all the locations, take the headset off, pat us on the shoulder and say, "A job well done, that technology is really impressive." And of course, we would be left unsatisfied because no one actually paid attention to any of the detail that we painstakingly scanned and put in there for their consumption. So we started thinking about it. What is the problem? What can we do to bypass it? We realized in order for people to actually care about their stories in these locations, we need to frame our photogrammetry scans like a work of art. We need to frame the relevant detail so that not only people notice those details, but also they enjoy looking at those details and try to think about why is that thing there. Now that's a very challenging thing to do, but we realize we need a game. We need to gamify our photogrammetry. We tried a bunch of different game loops. I am not going to be covering all of them. I'm just going to give you one example so that you have an idea of how we got to Puzzle in Places. So we were working together with one of our partners in Canada. They got state funding to do this documentary, and they scanned a bunch of locations which had cultural, or let's even say environmental relevance. And we wanted people to see that and notice it. So we decided to give people a compass. The idea behind the compass was people would take it in their hand and they couldn't just simply switch to the next location from the get-go. They had to first use the compass to find a bunch of clues we have hidden around the environment. And once they find a clue, they are allowed to go to the next location. So we user tested this idea, and we found out something interesting. So people like to play games. I think that's something very human in us, that we enjoy playing games. Playing games means we like to understand the rules, the mechanics, the game loop behind that playful activity, and we would like to be good at it. So what is the activity for them? Here's a compass, find the clues. And that's what people do. They would pick up the content, ignore everything in the environment, just look around, try to find all the clues as fast as possible, go to the next location, to the next, and then take the headset off, pat us on the shoulder and say, "Wow, the compass is really cool." And we are left dispirited again, because they actually didn't pay attention to the environments at all. So we learned from that we need maybe a different game loop, and we continue trying. Before I explain how this led us to Puzzle in Places, I would like to cover the path to Puzzle in Places from maybe a different route. We got to Puzzle in Places through two different ways. The first one was the matter of content, the question of content. How do we frame our photogrammetry content in a way that people actually care about it and actually spend time and emotions and attention to try to figure them out? The second route was the question of rendering. How do we render these locations? So as I said before, to scan a large location, you take thousands of photos. Thousands of photos create models of extremely high quality and dense information. That means millions of vertices and polygons, hundreds of 8K textures, and these type of high quality models are not practically renderable in real time, especially not on platforms that we aimed for. We would like to be able to render on mobile and also on high-end PC, right? And we would have to optimize these somehow. And that was the first question that came to our mind. How do we actually render these locations? The solution was to create a pipeline. So what do I mean with a pipeline? The idea behind a pipeline is this. You take a three-dimensional model or a mesh, you put it in the pipeline. So as input, a bunch of processes and stages, which are mostly optimization, happen to that mesh, but completely automatically. And at the end, you get a model that runs and is optimized and usable for your platform of choice. This could be mobile, as I said, could be a console, or it could be a high-end PC. So there are a bunch of different optimization stages that happen in our pipeline. I am not going to be covering all of them, although all of them are relevant to puzzling places, because otherwise we would not have been able to render this beautiful and intricate real-life location on Oculus Quest, which is practically, well, a mobile platform with a mobile chipset inside. The one stage I want to focus on is our segmentation. When you get a mesh out of the photogrammetry algorithm, what you get is one huge interconnected object. It's just one continuous giant topology. That's not very ideal for rendering. I'm not going to go into details of why that's not great for rendering, because that would be a bit too technical, and this is not a technical talk. However, it's not very practical because, you know, it's hard to kind of chop it up in a way that your computer can divide the work of maybe you render this part, I render that part, you render this part. And at the same time, it's really hard to clean them up. It's hard to maintain them, hard to pass them around. So we decided we need to chop these models in tinier pieces somehow. And again, because of performance and convenient reasons, we wanted to chop it up in a way that each chunk, so each segment afterwards, roughly has the same surface area. Again, bunch of different reasons why that's the case, which I'm not going to cover. But at the end, we want to have somehow a method where automatically these models are chopped up in pieces of equal size or equal surface area. So what we ended up doing is a Voronoi relaxation algorithm. It's what you see in front of you, but on a surface of three-dimensional topology. You take these red dots, you put it everywhere on a three-dimensional topology, and you move them around iteratively until they have more or less the same equal distance from one another. So you end up with all these different cells which have, well, equal surface area, and then you chop those cells up. We made that basically, and we got a bunch of, let's say, performance boosts from it and convenience. I'm not going to cover all of them, but just here's a very simple example. When you're creating a giant world, of course, you don't want everything in the world to be rendered at all time, right? As for why you do not want that, well, it's pretty straightforward. A lot of those details are not even visible to your camera, so why should you render them? If you have one huge object, you have no other option but to render it, because you have to send the whole thing off to your graphic card. But because we have these chunks of equal size, we can easily do calculation on a simple chunk, and if it's not visible to a camera, we say we are not going to render it. That's what you see here on the left, where the chunks that are not visible are simply called, and the ones that are visible, well, you can see them on the right. So how did this lead to the creation of puzzling places? I was working on a project and I was working with a model that has already ran through our pipeline. That means the model was already chopped in many different pieces. So I wanted to import this model in Unity engine, and something went wrong with the input process. As I imported in the engine, and instead of getting one, let's say, whole model, each chunk or each piece just got a random position and a random orientation. So you can imagine this very chaotic scene with each chunk flying in one direction. Looking at that, I made a joke. I said, maybe we should make a game where players put this back together in one coherent model. I made that joke because I was lazy and I didn't want to do that myself, which I ended up doing by hand, by the way. But the moment I said that, there were 3 of us in the office. We just looked at each other and we knew immediately, this is the game loop we have been waiting for. This is exactly the game loop we were looking for to our old problem of how do we frame our content in a way that makes people actually care about details. Why is that the case? Well, because it's inherent in the puzzling game mechanic and the puzzling game loop itself. Think about it. If you have a piece in your hand and you want to figure out how does this piece fit in with the rest of the pieces I see in front of me. That can be pieces you have never seen before, or maybe pieces you have already puzzled together to like a huge island. You need to pay attention to the details. You pay attention to details on several different layers. You pay attention to fairly low level stuff like color gradients, right? How does color change from one point of the surface to the other? You pay attention to line, you pay attention to textures, you pay attention to abstract forms, like here is a square and there is a circle. But you also pay attention to fairly high level semantics. For example, you recognize that there is a door on this piece, and maybe the door looks a bit arabesque. And there is a window on the other piece, and that one looks a bit rococo. And then you need to match these different details to try to figure out how they fit with each other. You will look at the color and think, maybe that color is being affected by the light of the window. And then you start thinking about how does an Arabic looking door match together with a French looking window. Something magical happens when you play this game for a long period of time. People pay such intense attention to everything in the location that they end up knowing the location better than if they were actually there. They notice details that they would have completely missed if they actually walked through these locations. And I think that's very beautiful. It's beautiful because, well, let's say over the many hours that people spend playing our game. So we have different difficulty levels. We have 25 pieces all the way to 400. And if someone is playing a 400 piece, well, they're typically having around 5 to 6 hours of playtime, more often than not even 10 or 11, right? So they start developing this personal attachment, this emotional attachment to the location, a deep understanding of what makes up the location and the stories inside it, and also their own personal stories of how they got to know the location. They remember the first time that they realized that those 3-4 funny looking pieces are actually a staircase. And the first time they realize how their staircase comes together with the entrance. Now, this is beautiful because it's bridging that gap of subjective storytelling, bridging that gap of subjective personal experiences. Because suddenly, people who knew nothing about this location can relate to people who have this location as part of their own personal experiences and history. And I think that's beautiful. We call this game loop gamified mindfulness. It's one of our main game field. The reason why we look at it that way is this is the state you go to when you're trying to, do mindful meditation. And it also happens to be the state that artists try to go into when they're creating art, and the state that they force the viewer into when they're consuming art, right? This is a state where you pay attention to details and you try to figure out how details match with each other. So that was the funniest story because we realized we have been making puzzling places for a long time already. We just never knew we were making puzzling places. The segmentation algorithm I talked about before, for example, practically chops a model into tiny puzzle pieces. We just didn't know we were making that. On top of that, we have been working with photogrammetry for years. So we had a lot of expertise on how to capture, how to clean them up, how to maintain them, how to render them, as well as a lot of contact and a reputation in the industry. Well, let's say with people who scan locations for a living. So we were very well positioned to make a game, a puzzle game about photogrammetry. The next step was to make a tiny proof of concept, which is what I did next. I spent let's say a month, not a long time, maybe even 3 weeks, creating a very rough prototype, which we tested in the team, and we decided this is the game we want to work on, and we want to make a game. There was a problem. We are not a game company, we are a tech company. And that, of course, creates a lot of challenges because we do not have a lot of experiences in making video games. We have made interactive experiences before, but not games. And the lack of experience means we don't know ahead of the time what is a good decision and what is a bad decision. So we decided to accept our weakness, which was the lack of experience, and make up for it with open development. We kind of try to bring our strength from tech startups, which is where we came from. And part of that strength was failing fast mentality. Try to figure out your questions by failing fast. Maybe you succeed, maybe you fail. And combining with this open development to try to, make up for a lack of experience. So what did open development give us? First of all, what do I mean by open development? Open development was we made a free beta, let's say demo, which we put on SideQuest for people to try. It was played by tens of thousands of people, which we didn't expect. We were really happy and thankful for. And we decided to use that platform to test in real time some of our ideas and try to get learnings from it. It was not enough for us just to put it out there for free. We wanted to also have, let's say, some sort of paid revenue thing where people can pay us to get more puzzles. We needed that because players' behavior or consumers' behavior changes a lot between when they get something for free and when they actually have to pay for it. So we launched also a Patreon campaign where we gave players 4 puzzles a month and they paid us some amount of money. We had around 1,000, I think, patrons at the end. So we wanted to find out a bunch of things. One of them was how fast can we make puzzles and how much does it cost? On top of that, we wanted to figure out what is actually a good puzzle. We didn't know that. We had our guesses, but we had to, again, lack of experience, so we had to figure that out. So we put out all these diverse set of puzzles from motorbikes to fighter jets to historical sites to try to figure out what people actually enjoy. We also wanted to better understand our demographic. Who plays our game, right? One of the fun things that we found out about our demographic is people of many different cultures play our game. It's not just the Westerners, but also people from Japan and many different locations also play our game. We also found out that the split in gender between our game is pretty much 50-50. Men and women both enjoy our game. Young people and children enjoy our game as much as older people. As a matter of fact, our average player base was around, let's say, 60 plus in years, which is very uncommon for a video game. Also, we had a bunch of hardcore fans who never played video games before. They had no interest in video games, but for some reason they really liked puzzling places. So these are all very valuable lessons to know because you need to know who you design for. So we also use the open development to test some of our game mechanics. I'm going to cover that in a few slides. And the open development has a bunch of different, of course, advantages, such as it helps you to catch rare bugs. It helps you for having a strong launch because you already have a dedicated fan base by the time you're launching the game. And it also made it a lot easier for us to get accepted to the main store because the game we were making was so different that we kind of did have to convince our platform holders this is an actual game and people are actually interested in it. People are spending hours and hours and hours into this game. So I talked a bit about understanding our topology, like of our viewers' topology or the gamers, like the people who play our game. Here's a good example. Because we had such a diverse set of players, we decided to try our best to have as much cultural diversity as possible. Like the top 3 puzzles are from Japan, from a famous castle to a kimono, to a Japanese storefront, which is a restaurant. But we also have a European castle from a Habsburg castle in Spain. On the right, we have a Middle Eastern mosque. We have a tractor. We have Mont Saint-Michel, which is a very iconic building. So we have all these different locations from around the globe trying to appeal to different type of players, and also to a great degree trying to communicate it between different cultures, right? It wasn't just giving Japanese buildings to Japanese people, but also helping maybe Westerners to better understand how does a Japanese storefront look like. So again, a bit about testing our game ideas, UX, and game mechanics. As I said, we have not such a great, let's say, reserve of experience to know what constitutes good decision. And also, we had a very tough challenge of designing for a young medium. So what do I mean with a young medium? VR is new, right? That means there is very low game literacy between the players of VR. What do I mean with a low game literacy? Think about an Xbox controller or a PlayStation controller. You can give that controller to someone, your typical gamer, and they can be playing a game they have never played before, and they immediately know that with the left analog stick, they can move around the main character, and with the right one, they can control the camera. This is amazing. They have this literacy of using this without a tutorial, right? If you want to know how complicated that input scheme is, give it to someone who has never used the Xbox controller. They would be so overwhelmed with using two analog sticks at the same time. This control scheme was so complicated that the first time they brought it out, the critics said, this is never going to catch on, it's too much. But game by game, tutorial by tutorial, people start getting used to it. And nowadays, it's just second nature to the most gamers. However, that's not the case in VR. Every, let's say, control scheme or UX you're giving to your player, chances are they're seeing it for the very first time, right? That means you have two options. Either you create a game that is so simple that everyone will get it, or you create tutorials that are so extensive that you wouldn't leave anyone behind. Both are hard to do. The second one was not practical for us because that would mean a lot of translation for all the different cultures that we were trying to aim for. So we went for the first. That gave us a very good criteria to design the game around. Puzzle in Places should be able to be played comfortably with one hand and one controller without moving around, sitting or standing, just looking forward without needing to move your head around too much. That forced us to really simplify all our UX in a way to make it compatible for such a simple controller scheme. Another problem with a young platform, or a young medium, is the lack of pre-existing solutions, right? Usually if you have a problem in game design, someone else has had a similar problem before, you just need to look at their problem and you have a starting point. However, in VR, that's not necessarily the case because there are not that many pre-existing solutions. One of these areas was art direction. So photogrammetry is a very tricky thing to art direct for because these assets are so intricate, they are so hyper-realistic, they are so sharp, and any complementary asset that you create need to match that somehow. Also at the same time, we realized pretty fast that the main attraction, the main reason why people play our game is the puzzle and these real-life locations. So whatever we create in the environment around us shouldn't distract people from the actual fun puzzling. At the time, as I was art directing Puzzle in Places, I was obsessing over Japanese woodblock prints during the Edo era. And one of the things I realized about these prints and the cultural movement at the time was, it was a try to capture the essence of an object, right? And at times, these painters would try to eliminate the concept of space itself. They would get rid of the horizon line, they would try to flatten the image, because the space itself is something that gets between your understanding and the true essence of the subject matter. I found that to be fascinating, and it kind of matched with what we were trying to do in Puzzle in Places. So we did something very unusual. Typically in VR games, when you go to a virtual environment, they add all these grids on the ground, the horizon, all these depth cues to try to wow you with the concept of a virtual space. We try to do the opposite. We got rid of the horizon line. We try to get rid of as many depth cues as possible, constraining the depth cues only to background, middle ground, and foreground, very similar to a woodblock print. And we saw that that worked. It was as if you took a veil and thinned the distance between the actual person and the puzzling interaction. So, to just summarize a bit, we were a tech company, very fascinated, let's say, with the prospect of real-life location, the environmental storytelling in them, and we wanted to kind of bring those stories to other human beings to bridge that gap of understanding. And we realized pretty fast that we needed, well, some sort of game to achieve that. From that, Puzzle in Places was born. And we have been making the game since then. And we did open development because we didn't have much experience making games, so we kind of had to make up for it. And the game is actually not done yet. As you can see here, we have been putting out a lot of puzzles since the launch, some of them free, some of them paid. We're putting out monthly puzzles every month, between 4 to 6. We're always trying out new things. At the same time, for the future of Puzzle in Places, we have been working on multiplayer, and we are trying to further, let's say, enrich the player's experience within our puzzles. Thank you for listening, and wish you a good day.
本セッションは終了となります。セッションの聴講ありがとうございました。次のセッションページへとご移動いただき、引き続き XR 会議をお楽しみください。